First part of the narrated lecture for chapter 25 on protein and amino acid metabolism. So what we need to see is actually having through the digestion of protein the hydrolysis of all the peptide bonds that link all the amino acids, and that will give you a pool or a collection of amino acids. Just showing you here hydrolysis of the peptide bonds. So there's a cleavage and it's going to release free amino acids. Where does it start? Well, it starts in the mouth. And the reason why we're chewing our food is to actually break it down into smaller, more digestible portion. And the reason is actually to increase the surface area, and that will help the food to be better digested. And then you get into the stomach, where the acidic environment, which the pH is very, very low, very acidic, 1 to 2, is going to actually start to unfold tertiary as well as secondary structures of protein. Looking at the gastric secretion, where there is pepsinogen, that's a zymogen that is activated only under acidic condition, and that will give you the enzyme pepsin. Pepsin is stable and active at that pH between 1 and 2 and breaks the peptide bonds. Now, the polypeptides produced by the pepsin are able then to enter the small intestine. Now, here the pH is different, 7 to 8, so slightly alkaline. What it makes here is that the alkaline pH is going to inactivate the pepsin. And then you have enzymes that are secreted by the pancreas. Those are zymogen. And those enzyme proteases such as trypsin, chymotrypsin, and carboxypeptidase can actually help to further hydrolyze the peptide bonds in the protein that are so far partially digested. Now that's very interesting to look at the combined action of the pancreatic protease in the small intestine and other proteases in the cells of the lining of the intestine will help to complete the conversion of those proteins in the diet into free amino acids. Those can go across cell membranes and they can then be absorbed directly into the bloodstream. And this is here a concept map. Look at the dietary protein, goes into the mouth, broken down into smaller pieces to increase surface area. Acidic pH of the stomach is going to actually help to activate the pepsin. It's going to help break down those proteins into the small intestine. The pepsin is inactivated and protease take over, and they are going to break down further to make those amino acid, a tiny bit of dipeptide that can be carried and transported through the small intestine lining. And that's going to give this pool of amino acid that exists in the bloodstream.